Hi, my name is Morgan and I am a neuroscience researcher and an NSF GRFP fellow, which just happened last week. It was super exciting and I'm so sorry that I have not been putting out videos as regularly as I am supposed to. Supposedly I upload one every Wednesday, but I missed the last 2 weeks. I missed the first of the last 2 weeks due to some mental health reasons. I think I was experiencing some burnout, needed to take a break. I'm feeling much better now. And then the next week, I found out that I got the NSF GRFP on the same day that I was supposed to be recording a video, and there was no room in my mind to possibly be thinking about YouTube. If you're not familiar with the NSF GRFP, it is a huge deal in research. It's a very big honor to have gotten it, and I will definitely be making a video on it in the future for anyone who may be applying in future years. Just a quick plug, if you're not already following me on social media, go check it out. I'll list them here. Instagram and Twitter are the main places where I announce when I'm uploading videos, or if I'm going to miss a week, you might get some more information for that. I've also been uploading a lot of stuff to my Instagram stories, just of like personal life and also of things that are going on in the lab. Also, before I fully get into this video, I want to say thank you so much to everyone who's been subscribing. I reached 900 subscribers, which is absolutely insane to me. If you haven't already subscribed, please hit the subscribe button. It would mean a ton, and I do have a really fun video planned for whenever I hit 1,000. Now that I've gotten all of that out of the way, let's move on to the actual video. What am I going to be talking about? This is something that I just sort of casually mentioned in one of my previous videos, and since then I've been really wanting to make a video about it, and also both Don Krung and Jay Blaine, and both Don Krug and Jay Blaine, I'll put their comments here, asked for it. So here you go, guys. If you would like to ask a neuroscientist a question, please feel free to leave it in a comment below, or you can DM me on Instagram, or you can send me an email. Any of the ways of reaching out to me work. So this week we are going to be talking about muscle memory. Now, muscle memory is likely a concept that you were introduced to back in high school, maybe even elementary school. If, like me, you probably had a basketball coach who told you to do this motion every night before going to bed so that you would make your free throws the next day. I don't remember much of sports. That wasn't particularly my thing, but it's something that a lot of sports trainers talk about. But muscle memory can also be applied to a lot of other aspects of life. To give you a definition real fast, muscle memory is sort of one of those things that everyone kind of like knows what it is, but doesn't really like have a solid definition for. But what I think of it as is more of a phenomenon of long-lasting memory for skills, even whenever you haven't done that skill in a long time. So sort of like the one that most likely comes to mind is the saying that you never forget how to ride a bike, which is true because of muscle memory. This can also be applied to things like knitting and other fine motor skills, and even to sort of your daily routine. Everyone, in the morning you get up and you do certain activities whenever your brain's sort of on autopilot, and it can be really difficult to change those activities, and that's muscle memory. Because people are constantly asking for book recommendations, a series that I really love is called The Unwind series by Neil Shusterman. I'll put the book covers here. And it's about some kids who are living in sort of this alternative future where unwinding has become a thing, and essentially what unwinding is that lower class citizens will either sell their children or even themselves to sort of be taken apart for their body parts, and then upper class citizens will purchase those body parts and have them sewn onto them, sort of like a living Frankenstein situation. It's really interesting. It explores a lot of aspects of society and morals and different things like that. But one thing that the book brings up constantly is the aspect of muscle memory, which it uses muscle memory in a way that everyone kind of uses it, but also a way that is wrong, which is essentially in those books, say you purchase the arm of a famous baseball player, you would then be very good at throwing baseballs, which is kind of what people tend to think of as muscle memory. People think that your muscles have memory. It's what the saying is. If you break down the phrase muscle memory, it sounds like you're saying muscles have memory, which they do not. Your muscles are not made up of neurons and don't have brains. Fun fact that I learned while researching this video, squid tentacles have brains, so they have actual muscle memory, but humans do not. So muscle memory doesn't actually happen in the muscles. Certain actions do require a buildup of muscles, so you may need to go to the gym and do a repetitive action in order to build the proper muscles to do that action more frequently. But the actual memory of doing it and what makes you do it more often is your brain. Your brain is where the memory happens, which I know seems obvious, but the amount of people that I've talked to who think that muscle memory happens in your muscles is frankly way too many. And if you came to this video thinking that muscle memory happens in your muscles, I am not attacking you. I promise. This is a safe and welcoming place for people to learn new information. I'm very happy that you sought it out. That's very good. But a lot of people just sort of stop at muscle memory happens in the muscle. And that is where the mistake happens. So in order to properly talk about muscle memory, we do have to talk about memory in general for a second. Something that confused neuroscientists and psychologists and anyone who could possibly be interested in memory for a long time is the question of where are memories in the brain? And that's sort of the wrong question to be asking, because memories are stored throughout the brain. So once we figured out that memories are sort of located simultaneously, sort of like everywhere and nowhere at the same time, it was a little bit easier to figure out how memory works, if that makes any sense. I do want to preface this by saying that memory is not my main field of study, so it was a little bit difficult for me to understand, but I believe that I've thoroughly researched this video, and I, of course, as always, will link citations down below if you want to check out my sources and learn more for yourself. So once we figured out that memories could be stored and encoded in different ways, we began classifying them in different ways. So there are different forms of memory that are stored differently. The two main memories that people often talk about are declarative and episodic. Declarative memories are facts, typically, or what you believe to be facts. So like something that you memorize for a test is going to be stored like declarative memory. Episodic memories, the word episode is in there, so it's sort of things that have happened to you, life events. If you're remembering, say, like a birthday party, that's episodic memory. And these two things are very different. There are people who have problems with one or the other. And say someone has an issue with declarative memory, they may remember being in school physically, stuff that happened to them while they were in school, stuff that they did while in school, but they might not remember the facts to a test. So that's them remembering all the episodic factors and not any of the declarative factors. Muscle memory is a form of procedural memory, which is stored in its own unique way. So a lot, if not all, memory studies can be tied back to patient HM, who I've mentioned in a few previous videos. Patient HM was a man who developed anterograde amnesia, and anterograde amnesia prevents the formation of new memories. So he still remembers everything that happened to him before his incident, but he can't form any new memories since then. People were really interested in studying him because the fact that he couldn't form new memories was very useful in studying how memories are encoded and how they're stored, because he had the storage of his old memories, but he wasn't able to store any new ones. For example, he couldn't recognize the doctors that treated him every day or remember his nurse. And so he was a really interesting and important case in neuroscience. One test that the doctors ran on him was called a mirror drawing task. And I'll insert a picture of what it is because it's a little bit difficult to explain. But essentially, they tell him to, say, draw a star. But they block where his hands are, so he can't see his hands drawing the star. But in a mirror, he can see it. So everything's going to be flipped. And some, I think, art schools teach you how to do this. It is like a form of art. It's very challenging because everything that you're seeing is flipped, and moving your pin in one direction will like actually move a different direction in a mirror because mirrors are flipped around. So initially, the task is extremely difficult to do. But over time, your body and your brain will remember the task and will remember, okay, I'm seeing it in a mirror, so if I go this way, it's actually going that way, and you'll slowly improve at it. And this is what they saw with patient HM. Even though he wasn't able to form new memories, he was able to learn this new task, and over time, his performance of drawing this star improved. He was able to draw it quicker and with fewer errors. But each time they had him do this and they asked if he remembered having learned the task, or if he remembered mirror drawing or drawing a star or anything related to the task, he didn't, because he couldn't form new memories. But this shows the important distinction between procedural memories and declarative and episodic memories. So what scientists found is that declarative and episodic memories are stored more in the temporal lobe of the brain, which is around here, and in the hippocampus, which is sort of in the middle of your brain. But procedural memories are stored throughout the brain and are stored in places where the motor movements happen. So different parts of your brain are responsible for different motor movements, and all of those areas will sort of light up on a brain scan if someone is performing a procedural task and trying to remember it. So some of the areas where this happens are the motor cortex, which is involved in planning and executing movements, the basal ganglia, which is important in initiating movements, and the cerebellum, which is important in adapting your movements. Some MRI studies have shown that over weeks of practicing a different motor skill, a lot of them use juggling for some reason, the connections between different brain regions will increase. Mostly they'll increase between your visual cortex and your motor cortex, which is thought to improve your hand-eye coordination, because the more synapses that are communicating between the two areas, the more quickly information will be able to be conveyed from one to the other. There's also a thing you'll have to study if you're in the field of physiology or neuroscience or anything like that, called a homunculus. And a homunculus is this horrifying image of the motor cortex and which different parts of the motor cortex align to different parts of your body. The different regions that are larger are because there's more nerve endings, I believe, and so it's sort of, there's a lot more connections there. So like your hands are like a really large area because there's a lot going on in your hands. So neuroscientists and physiologists have sort of figured out this map of your brain showing how different brain regions line up to different body parts, and studies have shown that wherever muscle memory is increased, those areas of the brain also become larger. So the part of your brain that is dedicated to moving that area or sensing that area does enlarge based on that. Now, studies that go off of brain size are kind of difficult to evaluate because brain size doesn't always correlate to any actual physical results, and brain size is extremely difficult to sort of normalize across multiple people. But I did think that was really interesting. There's some interesting other stuff that can be talked about with homunculi, so let me know if you want a video on this like freaky image, because there is really a lot of cool stuff that we've found since being able to map these different parts of the brain. A fun fact that I found in researching this video is that there's actually 6 different types of muscle memory, but that was created by a psychologist, and whenever I was reading through the different types, it didn't necessarily translate over to anything that neuroscientists really discuss, or really to any real different forms of memory and memory storage. So it's not something that I'm going to discuss here, but I will have an article linked in the description if you're curious and want to check it out. Now, I would be a bad scientist not necessarily doing my due diligence if I didn't mention that there are some people out there who theorize that there are cells that remain in our muscles or near our muscles that help in forming new muscles. So like wherever you go and you train and are moving your body in a particular way every day, that they will help the muscles regrow in a way that is advantageous to that. And while I think that's really interesting and definitely something worth looking into more, it's not neuroscience, and it's not necessarily muscle memory in the traditional sense, because regrowing muscles or forming new muscle fibers, I guess, is not necessarily the same thing as remembering something. Also, like I said, it's not necessarily neuroscience, and I'm a neuroscientist. I am not a cell biologist. I'm not a kinesiologist or anything like that. But again, if you're interested in learning more about this, there will be a paper linked below on that as well. So that's really all that I have to say about muscle memory. I genuinely thought that there would be more information on it, but it does seem like a lesser studied subject. Also, doing memory research is extremely difficult, so I totally understand why it would be harder to publish papers on it. And again, it's not necessarily my thing, so maybe there is more stuff out there, but I haven't found it. But I hope that you enjoyed this video. Like I said at the beginning, if you have questions that you would like to ask a neuroscientist, please feel free to leave them in a comment down below or email me at askaneuroresearcher@gmail.com. Follow me on all my social medias, the link here, to keep up to date with me, and check out my Instagram stories and my TikToks to see what I'm up to. Also, if you haven't, please hit that subscribe button. Like I said, I'm getting near to 1,000 followers, and I'm super excited for what's going to be happening with my channel once I hit that. So I would really appreciate you helping me get there. So with all of that, I will see you next Wednesday. Bye.